Okay, good. That's obviously good. Okay, which of the following is true when perform a simple harmonic motion about center point? Acceleration always away from O? Is it acceleration always away from equilibrium? No, acceleration always towards equilibrium kan? Betul tak? Acceleration always towards equilibrium. So the first one is wrong. Okay, are you following?
Yes.
And then the acceleration and velocity always in opposite direction. Is it? Acceleration and velocity always opposite?
No.
No. Acceleration and displacement. Yeah, not acceleration with velocity. Look at this graph again. You see? I see acceleration and velocity same direction. You see at the acceleration and velocity same direction. You see? Same direction. The only one always opposite. The only one always opposite is acceleration with displacement. The red and the blue always opposite. See that? For velocity, sometimes same direction. See? Same direction then and then the block accelerate. Okay? Accelerate. If always opposite, how can it accelerate? Okay, so this is wrong. So okay, so maybe I should make some corrections. Yeah. Sometimes this is not away, it's towards. Always towards, and then this one should be displacement. Acceleration and displacement from always in the same what is this? Always opposite kan? Yeah. So I think it's the D lah, the only answer. The graph of acceleration is the graph of acceleration versus displacement is a straight line. This is KBKK. I haven't thought about this one, but in you think yourself. Acceleration and displacement is a straight line. Are you sure? You didn't realize because
Yes.
but now actually if you think back, yes lah, macam betul lah, that should be acceleration and displacement actually is a straight line. You see, it's a y equal to mx graph. He's talking about what? He's talking about acceleration and displacement kan? Acceleration and displacement, that means is what? Is what kind of graph? Linear. A equal to negative omega square y. How do you draw? You want to draw what? You want to draw this acceleration and displacement. That means A versus y kan? Betul tak? So A versus y. This is actually y equal to mx graph. This is a linear graph, straight line. How do you draw? So is actually negative gradient. This is the gradient. Negative omega square is the gradient, and it's a negative gradient. That means, and this one pass through origin. This graph pass through origin. That means, I talk so much to you. I wonder, should I say the same length of things again to other class? Yeah, I really take out my breath. That's why I want to record this session. The other class, I think, just watch my video lah. Okay, so this is this is the gradient is negative omega square. It's a linear graph. Yeah, it's a negative gradient. You know, your class, I teach a lot of things. I teach a lot of things. I'm not sure whether it's necessary or not. Okay, so this is a gradient is negative gradient. Yeah, negative gradient. So negative omega square. So this the graph is supposed to look like. Yeah, and then let me tell you something. This is the amplitude, and what do you think is this value? This is actually the maximum. When you put negative a and a, when you put inside the equation. So when you put we already learned about that. You see that when you put y equal to a, what is the a maximum? A is maximum, omega square a kan? See that? So here, if we put a into this equation, then we get what? this get A, we get negative omega square A. Understand? Opposite direction. They're always opposite direction. When y is positive, A is negative. Yeah, and A is maximum. Y is maximum. Yeah, when y is maximum, A also maximum. Okay. So see, opposite direction. One positive, one negative. Acceleration and displacement always opposite direction. Okay. So if we put y equal to negative A, what is the acceleration then? What is the acceleration? Acceleration is negative. Wait. Y is negative A. So negative become positive. So it become positive. So the graph is graph above the y-axis, above the the okay, whatever. So omega square A. See that? When y is negative, A is positive. Okay, that's then you can calculate the value. Let's say the question gives you amplitude. Then you can calculate the value and you can draw a graph with labels, with value label. Okay, that's it. So the answer is D. It's true. It's straight line. You need to think. You need to think. When a mass suspended on a spring is displaced, the system oscillates with simple harmonic motion. Which one of the following statements regarding the energy of the system is incorrect? Okay. Mass suspended on a spring is displaced. The spring oscillates with simple harmonic motion. Which one of the following statements energy of the system is incorrect? Energy, yeah? Regarding energy. So, energy, yeah? Regarding energy, he asked, is a spring mass system. Okay, oscillate with simple harmonic motion. So which one is incorrect? Not correct, incorrect. So energy means you have potential energy, kinetic energy of the block, and total energy. Yeah. Okay, so first of all, okay, it's very hard. Yeah, so much words. So I like to use highlight to help me. Potential energy, kinetic energy, and this is a sum of energy. This is the potential energy. So it's helping me. Yeah. Okay, so the first one is potential energy is minimum. Okay, potential energy minimum when fully extend. I like to look for keywords. That's why I like to highlight or underline something. Help me to solve the problems. So these are the keywords. So that means it's at the amplitude, correct or not? Fully compressed or fully extend. That means it's either positive amplitude or negative amplitude. So is it minimum? Is it the potential energy minimum?
No.
No. So it is wrong. So this should be maximum, isn't it?
Yeah, maximum.
Should be maximum. The answer is A lah. Woo! The answer is A.
So fast.
So potential energy is maximum when fully extend lah, kan? Because spring is store most energy when fully extend or fully compressed. Maximum. So kinetic energy has maximum value at equilibrium. That's correct. Equilibrium, y equal to 0. K max. Good. Correct. This one we should use green. We know that all the rest is correct, kan? So this is correct. This is correct. Can you see it? I cannot see. So this is correct. Yeah. So K maximum at equilibrium. That's correct. And then sum of energy is constant. That's correct. And then potential energy is maximum when object is at rest. You see, this is KBKK. This is key, but I haven't talked about rest. That means it's talking about velocity. When velocity is 0. K max. No. This is potential energy max. Is it maximum when at rest? The object at rest at which position? The object at rest at which position? Look at the simulation. If you can remember my simulation, you can imagine things, Can imagine, not the imagine all nonsense. I mean imagine physics concept. Imagine. So you see, velocity at rest at amplitude. See that? Velocity at rest, amplitude. The block at rest at amplitude. Where is it? So this one is an amplitude. Yeah. Y equal to amplitude. So potential energy is maximum, correct. That means it's fully extension. Fully extension, block at rest. That means the kinetic energy at rest. That means kinetic energy is 0. Where has the energy gone? Where has the kinetic energy of block gone? It gives back to the spring. Yeah, the block give back the kinetic energy to the spring, so that the spring has maximum potential energy. The block has 0 kinetic energy. Because now it's at rest. Maximum extension. Okay, very good. I can say very good. Theory questions. Yeah, concept question. So this kind of question lah will come out in UPS. In UPS. Yeah. So very challenging question. Okay, so now look at this graph. This graph actually is the same as that graph I drawn. Yeah, the same as this graph I have drawn to you. You know this graph. See that graph. A omega and A omega square. A omega. Just pay attention to this part lah. Amplitude A omega and A omega square. And this is a sine graph. This is a cosine, and this negative sign. And you know why already, yeah? Period, 2 period. Okay. You read yourself. I think you can understand by reading yourself. Yeah, I've gone through everything. Total energy is constant. Also, I teach already. You read yourself. If you don't understand, you still read yourself again. Look back my video. Yeah, velocity is 0 means no kinetic energy. Equilibrium, potential energy is 0 because no all the form in the form of kinetic energy in the block. Yeah, because no extension. Yeah, I discussed. Okay, let's look at this question. A spring mass system can oscillate with simple harmonic motion because a compressed or stretched spring has which kind of energy? A stretched spring has which kind of energy?
Elastic potential.
Yes, elastic potential energy. Good. At what point of pendulum has maximum velocity? Pendulum is just like spring mass lah. Yeah, pendulum is just the same graph as this one. Yeah, it's not, this graph is not just for spring mass system. It's also for pendulum. Yeah, pendulum, that means the one oscillate left and right. It's the same graph. Okay. If you notice, the spring mass and pendulum, they also velocity 0 at amplitude, velocity maximum at equilibrium. It's the same thing. Okay. So what point pendulum has maximum velocity? I give the answer already.
A.
Yes, at lowest point. That means at equilibrium, kan? At equilibrium. Y equal to 0. Yeah, at lowest point. So maximum velocity V max. Yeah. You substitute. You use this equation. You substitute y equal to 0. You substitute y equal to 0. You substitute y equal to 0 equilibrium. You get V max A omega. Okay. You can do calculation now, not just oh like this. No value one. No value. Now you got values. You can calculate all the values. You are physicist now. You are physicist now. You can, instead of just storytelling, now you can calculate value. Lowest point. Good. Period. What's period? Remember the period I told you just now? Period of spring mass system. Period equal to 2 pi square root m over k. This equation is similar to what equation? K equal to m omega square. Remember that? I derived for you. I derived for you just now. Okay. Actually, it come from all this, and got this. Okay, it's the same. It's the same thing. Wow, I wonder I should teach. I think in the other class I just asked them to watch video lah. Okay. Okay, so period m over k, force constant. So period and frequency depend only on mass and force constant. Like I said just now, if you have at higher mass, it oscillate longer period. Longer period means slower. Do you understand this? Longer period oscillation means slower. The oscillation, slower oscillation. Slow oscillation. Okay? So period and frequency depend only on mass and force constant. Does not depend on parameter of motion, amplitude. It just depend on two things: mass and spring. That's it. It doesn't depend on other like amplitude. No. Yeah. You know, you understand what is this? You understand apa maksud dia? That means, let's say you have a spring, you extend it to let's say amplitude 10 cm, and you let go. It oscillate with, let's say 10 second. Kan, period 10 second. Okay, understand? Now let's say the other experiment, you extend it to amplitude. Now I put 2 times amplitude. Amplitude 2, I put 20 cm. What is the period? What is the period 2? Class? Amplitude 1 10 cm. So period 1 is 10 second lah. Let's say lah. Yeah. If amplitude I put it to 20 cm, what is the period? What is the period? Plus, where are you now? What is the period? Huh? What is the period? If let's say I now extend to 20 cm and let it oscillate, what is the period of oscillation? Will it oscillate because longer distance already kan? Last time it oscillate with you know, just around here, it oscillate around here. Now I oscillate, I make it to 20 cm, and now it oscillate bigger amplitude, longer distance. Oh, so does it take a longer time?
Yes.
No, it says here not depend on amplitude, so it's still 10 seconds. Understand? It's still 10 seconds. This is where I got you. Your misconception. Your misconception. So it does not depend on amplitude. That means if you oscillate 10 amplitude of 10 cm, the period is 10 seconds. If you make it oscillate 20 cm amplitude, it's still 10 seconds. It's just that longer distance, it just try to oscillate faster. But the period end up same 10 seconds. Okay. Why? Because the formula just show that period only depend on mass and K. The period only depend on mass and spring constant. The period only depends on mass and K only. Yeah? No amplitude. Understand?
Yeah.
Formula tak ada simbol amplitude di situ. Tak ada formula simbol amplitude. Oh, so kasih tambah amplitude. So period pun bertambah. Tak ada. Formula tak ada amplitude. Formula cuma ada apa? You sebut. Kalau you sebut you sendiri ingat. Formula ada apa?
Mass and spring constant.
Ya, mass dan spring constant sahaja. So, period hanya bergantung ini dua faktor sahaja. Tak bergantung pada amplitude. Faham tak? Dan satu lagi, di sini dia cakap tentang frekuensi kan. Kenapa tiba-tiba ada frekuensi? Anybody? Can you tell me? Kenapa ada frekuensi pula? Apa kaitan frekuensi dengan period?
1/T.
Apa? Betul-betul 1/T kan? So maksudnya period ialah okay, kita tahu Frekuensi ialah 1/T kan, betul tak? Boleh juga tukar menjadi period ialah 1/F, tahu tak?
Ya.
So maksudnya 1/F, ini period, kasih tukar kepada 1/F menjadi 2 pi 1F 2 power pi MOK, begitu. Faham tak? So maksudnya tukar lagi, F ialah means ini terbalikkan, square root 2 pi, ini K/M. Terbalik kan? So maksudnya apa? Boleh nampak apa? Boleh nampak apa di sini? Kalau mass semakin besar, kalau mass yang besar, frekuensi jadi rendah. Betul tak?
Betul.
Kalau objek yang berat, dia oscillate slower kan? Oscillate slower, frekuensi rendah loh. Faham tak? Oscillate slower. So, period meningkat tetapi frekuensi menurun. Period meningkat sebab dia inversely proportional. Kalau period meningkat, frekuensi menurun. Nampak tak? So, that's why dia kata period ini boleh tukar kepada frekuensi. So, that's why di sini dia ada cakap frekuensi dengan so, di sini ada cakap period dengan frekuensi. Ada dua benda, period dengan frekuensi. Sama ada period atau frekuensi, mereka bergantung pada mass dan force constant of spring saja. M dengan K saja, tak bergantung pada amplitude. Itu saja loh saya nak explain. So condition for spring mass system, condition, dia ada condition jugalah. Cannot exceed the elastic limit. Must obey Hooke's law. No air resistance and surface friction. Must no surface friction. Kenapa? Because kita punya simple harmonic motion ialah apa? Kita punya assumption ialah apa? Kenapa tak boleh ada friction? Kenapa? Balik kepada kita punya asal punya. Without loss of energy. Because SHM, no loss of energy. All energy is just in the form of what? Potential energy of the spring and kinetic energy of the block. No energy loss due to heat. Kalau ada energy loss due to heat, ini total energy tidak constant sudah. Tahu tak? Tidak constant sudah. Dia ubah sudah. Faham tak? So, mana sudah ya? Itu dialah. Itu cerita dia. Okay, no friction. Okay, so wait, go back to the spring. Tadi spring mass kan, M/K. Kalau pendulum dia L/G. Kalau L/G dia bergantung pada apa? So tadi kata period ialah 1/F kan. So macam ini formula pun boleh tukar kepada 1/F. Period is 1/F. 1/F equal to 2 pi square root L/G. So, nak tukar lagi, dia boleh jadi apa formula lagi? F equal to 1/2 pi square root G/L. Itu dialah. So, kalau kita boleh bayangkan, kalau spring yang pendek, kalau spring yang pendek, macam mana? Kalau bukan spring pula. Kalau pendulum yang pendek, frekuensi tinggi kan? Betul tak? Dia kalau kamu buat eksperimen kan? Kamu buat eksperimen simple pendulum kan? Kalau pendek macam mana? Laju tak? Laju kan? Laju tak? Laju kan? Laju sampai you tak sempat nak kira kan? You nak kasih panjang sikit kan? So kalau pendek dia frekuensi tinggi. Ya, kalau pendek frekuensi tinggi. So dia punya period pun pendek, so dia cepat, dia fast oscillation. Understood?
Yes, sir.
Kalau pendek dia punya period rendah, so fast oscillation, frekuensi pun tinggi, begitulah. Dia bukan bergantung pada L length saja, dia juga bergantung ke gravity. Gravity ni tak boleh experience lah. You kena pergi bulan. Kalau you nak buat eksperimen, pergi bulan. Pergi bulan sana, you banding dengan you balik ke bumi dan you banding. Mana punya oscillation lebih laju? Di bulan atau di bumi? Siapa pernah pergi bulan? Saya ada. Saya pernah di mimpi pernah pergilah. Saya di mimpi pernah pergi. Ya. Okay, so gravity juga bergantung, ya. Kalau gravity, okay, kita boleh bayang, ya. Kita boleh buat assumption. Kalau gravity semakin, let's say, di sini, gravity semakin okay, di bulan, let's say di bulan, kita nak tahu apa berlaku di bulan. Kalau gravity rendah kan, di bulan kan, gravity rendah, so frekuensi pun rendah. So oscillate slow. Understand?
Yeah.
So at the moon, low gravity kan, low gravity, so frequency also low, slow oscillation. Itu oscillation di bulan dia jadi perlahan, dia tahu tak? Sama macam boleh bayang sebab gravity rendah kan, gravity rendah, so di mana ayunan jadi perlahan di sana. Perlahan di sana. Kita punya grandfather clock pun jadi perlahan. Dia jam jadi tidak tepat nanti, ya. Okay, so itu dia lah kalau gravity. So dia bergantung, period juga bergantung pada gravity juga. Tapi satu, period is independent of mass and amplitude also. Sama juga tadi kalau saya kasih besarkan, kasih dia punya theta itu kasih besarkan berbanding dengan theta yang kecil. Atau itu maksudnya amplitude lah kan, amplitude. Betul tak? Adakah dia punya period akan ubah?
No.
No. Independent of amplitude. And also mass. Saya guna bola yang besar dengan bola yang kecil. Ya, saya banding oscillation dengan bola yang kecil dengan oscillation yang bola sangat heavy. Mana punya lebih laju? 1 gram atau 1 kilo? Nampak berat macam laju kan? Mana punya oscillation lebih laju? 1 gram atau 1 kilo?
Sama aja.
Sama sahaja, betul. Kalau ini 10 second, ini pun 10 second juga. Okay? Independent of mass. Okay? Why? Because formula tiada amplitude. Formula tiada mass. Nampak tak? Mass tak ada. Tapi spring mass system ada mass. Spring mass system ada mass. Bagi pendulum, tiada mass. Tiada mass, tiada amplitude. Boleh faham? Condition for simple harmonic motion must be, angle must be small. The spring need to be inelastic. And only gravitational force and tension in the spring act on the pendulum. Okay, so I think that's it for last 2 question. And then ini chapter lain sudah. Chapter lain sudah ya. Chapter 7.4. Mechanical wave. Ini banyak. Dulu kita cuma explain oscillation of one particle. Now you sudah faham oscillation of one particle. We go for oscillation of many particles. Okay, jangan gentar. Saya sentiasa bersama dengan kamu, ya. Okay, so kita lihat soalan yang pertama ini. The period of pendulum may be decreased by period of pendulum. Period of pendulum bila apa formula? 2 pi square root L over G, kan? Period, how do we decrease? How do we decrease? Decrease the length or increase the gravity lah. Betul tak? That means decrease period means fast oscillation, tahu tak? Fast oscillation. Ini frequency increase ni. Kalau period decrease, frequency increase. Okay, fast oscillation. So, how? Pendulum.
Shortening the length of pendulum.
Betul, shortening the length. Mass tidak ada kan? Tadi dah cakap mass tak ada. Moving the equilibrium point. How do you move the equilibrium point? Boleh move kah? Tak boleh. So tak adalah, mustahil ya. So shortening, that's correct. So shortening the length, that's correct. Brilliant, excellent, exceptional. Okay. Okay, a bob vibrates up and down on a vertical spring. If the period of the motion is 2 seconds, what's the frequency? Okay, this is about period and frequency. The bob vibrates up and down on a vertical spring. It has period of 2 seconds. What is the frequency? Okay, write it down. Period is 2 seconds. Vibrate up and down. It's a spring. It's a spring mass system. What's the frequency? Oh, just 1 over period kan? So it's 1 divided by 2. So it's 0.5 hertz. What does it mean by 0.5?
Half.
So it is, yeah, betul. This one you need to know the definition of frequency. What is frequency? The number of complete cycles in 1 second. Betul tak? In 1 second, how many cycles you make? You must know the definition. Very good lah. All this, all these. So this is a half cycle. One half cycle per second. So this answer is donkey lah. Yeah. So it's actually 0.5 hertz. That means 0.5 per second. You understand? This is actually 0.5 hertz is per second. Or you can say 0.5 oscillation in 1 second. Itu maksud dia. Yeah. That means it's one half. One half actually is half lah. Actually is half. Half cycle per second. Yeah, this is actually half. Half maksudnya half. Yeah, half hertz. Ataupun half oscillation per 1 second. Okay, understand everyone? Okay, so I think that's all for today lah. Yeah, that's all for today. Thank you for joining. How many available people here? All of you are still with me. Very good. Is Danish here? Huh? I don't want to look. Okay, so I hope that all of you are here. So okay, thank you for making this video a success. I will upload this video so you can kalau tak faham apa-apa boleh tengok balik ya. You boleh skip ke tempat yang kamu tak faham dan tengok balik. Okay, thank you very much. See you in the next class. Okay, bye.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.